putting their first step towards analytics, and some of them are having queries like what is business analytics, whether it is a right track to choose or not. So this webinar session will try to help you answering all those questions, and we'll try to uh, uh, project the main key points of business analytics and what is the market trend, what will be the future, and what is the job trend of when you learn business analytics, and whether you will also on this process will also understand whether you can switch to business analytics or not. Somebody who is already experienced in IT field, uh, whether you can switch to business analytics or not, so that you'd understand through this whole effort of this webinar session. Okay, so this is the agenda for today. So as we say, business analytics is all about analyzing data, right? All about analyzing data, because none of a business can work in this competitive world. None of the business can work without data. Even take any shop, even a cake shop, okay, even a small cake shop also has to keep in mind like what is the business that it has run for the last few months or a few years, and based on that it has to take strategy, right? What kind of cakes or what kind of foods are being sold high, what kind of foods are not getting sold properly. So based on all the past data, it has to run the business, right? So data is the important thing. So now as we are moving towards the term called big data, everywhere you go you see big data, right? You see Hadoop, you see big data. So we'll try to first understand what is big data, what is the definition of the big data, and when we should say the data is actually big and we should use big data ecosystem. We'll first learn that, then we'll move into what is business analytics, and as a business analytics, where do you sit inside the industry? Where do you sit inside the industry where data is there, right? And we'll also try to understand what is data science, what is the field data science, why the data science field has come from and where it has come from, and what are the key components in data science, and where does analytic course or a business analytics guy sits in the data science area. And because this whole course is with R, so we'll be teaching business analytics using R programming languages. We need to know what is R, right? What is R and why R being used, and why not any other programming languages? So we'll see that, and then we'll see some key companies who are actually using R for their business analytics purpose. Then we'll go through some market demands, future market demand, current market demands, and we'll see the some trends, how the market demand was previously and how the demand is currently going on, and what should be in the future. Uh, uh, what should be in the future? Then we'll see some case studies, and we'll end the session with some open questions from the case studies, which can be learned, which can be answered once you have become an expert in business analytics. Okay, so I got a question. Hadoop is a programming language or a big data? Hadoop Hadoop is an ecosystem. Hadoop is not a programming language, it's an ecosystem. Like Windows is an operating system, right? It's an ecosystem. Windows has many more components inside it. Linux has many more components inside it. Similarly, as you know that Linux has its own file systems, right? So similarly, Hadoop is an ecosystem. Inside the ecosystem, it will have a mechanism to store file. It will have some SQL programming capabilities like Impala or Hive. It will have a mechanism to transfer data from outside like Oracle, MySQL, or even any other databases inside Hadoop. Um, so that's a complete ecosystem. Okay, Hadoop is not just a programming languages for big data. It's an ecosystem for the big data. How long this session will be run? We will try to finish it within 1 hour 30 minutes. Okay, so the session will take 1 hour 15 minutes, and we'll keep the session open for any questions from your side. Okay. Okay. So what is big data? As you are looking at big data. So if you remember earlier, earlier when in 1990s or even 2000, like in the 2002, I got a first computer gifted from my father. In that, I used to have a hard disk of 40 GB. I was very happy with that. So today, when I have a laptop, I have a laptop of hard disk size of 2 terabytes, right? 2 terabytes is approximately 2000 gigabytes. So now, but when you go to the companies and their companies hardwares, you may see petabytes of hard disk are being installed. So now the world is such that look at that example. For example, look at YouTube, Facebook, Twitters. These are the company who doesn't create data, who doesn't create data. As a user, we create data. As a users, we create data. Uh, Brundesh, somebody is not able to hear anything. Can you help him? Tapasya. So as a user, we are creating like on the YouTube, we go and upload the video. On the Facebook, we post something. On the Twitter, we post something, and people follow us, right? Then people reply to it. Then on the counterpart, people post something else. You upload a video and other people watches it. Then based on the top of that, what YouTube does is YouTube put an advertisement, right? So YouTube, Facebook, even Orkut, which is dead now, Twitter, these are all, they don't generate, but we as a third party user are generating data. So assume what is the population of the world, and if even if 10% of the population of the world uses internet, so how fast the data is growing, right? So now by 2020 we will have 40 zettabyte of data in the world. 40 zettabyte is 10 to the power 9 gigabytes, 10 to the power 9 gigabytes, which is huge. Okay, which is huge in size. So every day, every second, the data rate, the data that is coming is growing. So every day the data is growing, right? So we have to have a mechanism because every day the volume is increasing. So when the volume is such high at any particular time, when the data is such high, then you have to use big data. Okay, that's the first sign of you should be using a big data or a big data ecosystem. The second sign is volume. Let's say, for example, you have a hard disk of 1 terabyte, okay, in your laptop, and your company says you have to work on a data size which is equal to 150 GB, which is equal to 150 GB. Now the thing is, uh, so what you do is you went ahead and instead of 1 terabyte, like 100 GB of hard disk, you requested the your hardware section to install a 2 terabyte or 200 GB hard disk. So 2000 GB hard disk. Sorry. So let's say 1.5 TB has been asked to. I mean, the data size on which you will be working is 1.5 TB, right? That is 1500 GB data. We have data size of that size it is. If you download the Facebook, some portion of the Facebook data, it will be more than 1.2 TB data. Now you went ahead and just installed a 2 terabyte hard disk and start working on it. Now assume that the every day only 100 MB, every day only, let's say 10 MB of data gets added on the 1.5 TB. Every day only 10 MB of data gets added. So to to actually run out of so for to actually the 2 TB hard disk to run out of the memory, it will take years and years. Okay, it will take years and years. So you actually do not need to do anything besides installing a 2 terabyte of hard disk instead of one terabyte of hard disk, right? And you can still work on a single system. So if the rate at which the new data or the streamlined data is coming into the hard disk, if that is not high, then still you can live with a bigger size of a hard disk, right? But assume that if I say, okay, you start with 1.5 TB of data, but every day 1 TB of data, 1 TB of, sorry, every day, let's say 1 GB of data will be added to your hard disk. One, so extra you will, every day you will be, there will be increment addition of 1 gigabyte of data. Then within 500 days, right, within a year or year and a half, the data, the hard disk size will be full. Within a year and a half, the hard disk size will be full. That means within 2 years you have to again change the hard disk. So that's, so just changing the hard disk is not a good idea. So in that case, probably you would need to have a big data ecosystem where there will be multiple machines with each of them having a hard disk, will be tightly coupled with each other in a parallel processing, like almost like a parallel processing architecture. And every computer can work on a small portion of the data out of that 1.5 terabyte of data. So velocity of the data is also important. Now let's go to the third aspect of why you should be using big data is a variety. Now, earlier in the earlier world, when in the 90s, the data, when we say electronic data, it was only tables, it was only databases, it was only Word files, right? Microsoft Word files, Microsoft Excel, some Oracle databases, and all. When we moved to 200 like 2000, in the millennium, we started getting lots of more databases, right? Lots of more databases. Now when you move to 2010, we started getting Facebook data, we started getting Orkut, we started getting YouTube and all. Now look at Facebook, YouTube, or Orkut, or now Twitter's data. What are the kind of data you get? You get comments, you get feeds, right? You get Twitter feeds, you get comments and all. So those are not. So earlier when the data was in Excel, it was all table data, right? It was all structured way of the data, having rows and columns, and you can easily understand the data and do any small programming, and you can get the inside property of the data. Now when the data is in unstructured format, like when the data has comments, are plain English written by people, or even not even grammatically correct English. People write anything, right? When they comment, they just use short form of a word, and they don't put grammar correctly. They just say, I mean, it's like on the way you chart using two guys, when two guys chart on a chart window, the same way these days we are also posting comments and feedbacks, right? To the Flipkart, you, when you buy a shoe, you whether you like the shoe or not, you just go and put some comment, right? Now Flipkart has to go and analyze those data, has to go and analyze the data. So the data at which the, so now look at in terms of Flipkart company. Let's say you are the CEO of a Flipkart company. You wanted to know how your products are going, how is the sale, whether the people are happy using your products or not. So in that case, you will also need to say is the current sales data, like how much sale has happened in the last quarter, how much sale is happening every day. So that is a structured data you'll be getting, right, from any database. But if you wanted to know how people are liking, whether the people are liking my products or not, how are they commenting, how are Flipkart products are being compared against Amazon product. So those will be coming from the comments from the customer, right? And that comments is unstructured data. It's all text. So now when the data variety are used, then we have to use a big data ecosystem. Okay. So I got a question. Big data is about processing the data, or uh, we can manage the data by migrating it to existing to database such as. Yeah, big data is an ecosystem. When I say ecosystem, let's say your data is earlier your data is in a some RDBMS, let's say Oracle databases. Now, Oracle databases cannot contain the data which is already large in volume, and every day large amount of data is adding to that, right? So there, what the need is, now port all the data from the Oracle database to big data ecosystem, where instead of putting the data in one large system, we will have a small scale hardware of thousand, let's say 1,000 systems will be integrated inside a big data ecosystem, and this data will be will be will be taken from your Oracle database inside the let's say Hadoop ecosystem, and the data will be splitted into different into parts, into equal size of parts, and will be stored in multiple machines, and the mapping of which portion of the data is stored in which machine will be kept inside one master machine. We call it a name node. Okay, so there will be a person whose name is a name node, which is a master machine, which will keep a mapping of where my data are sitting inside the 1,000 system. Okay, that is how the big data system works. And for processing, we use different kind of, like we use Impala, we use Hive as a query language, and you can actually go and query those data to know something. And if you want to work on it, you can use R, you can use Java, many you can use Python, all those languages for programming. But there will be a library which will communicate from your Java program to the Hadoop ecosystem, which will communicate from your R program to the Hadoop ecosystem. Okay, and that is how the big data ecosystem works. Did I answer your question? Okay, so we saw that the variety of data is also important. Now, veracity. When I say veracity, veracity means confusion in the data. Okay, see, all the effort is for business. All the effort is for business. We as a single human being sitting inside a home using a home computer, we cannot set up a big data ecosystem. These are for big companies, right? Big companies who can have afford hardwares and who can afford people to maintain this big data ecosystem. So these are for big business. Now, why they need to do it is ultimately they wanted to make profit out of analyzing the data. When we say they will analyze the data, means after analyzing the data, they will going to take some decision based on the patterns inside the data, right? So now what happens is, let's say there are 10 executives in the company, and you just show the data to them. Let's say you just show some data to them. Now what will happen is, generally we we cannot look at the whole data set and try to find a pattern. Instead of that, we go and we take a sample of the data set, we take a small sample of the data set, and we work on it, and we find some patterns. Now what happens is, out of the 10 executive, it may happen that 7 executive will agree with the sample result, and 3 executive will still ask questions. Okay, how can I be sure that the result that you got from the sample data will holds true for the whole data? It may hold true, it may not hold true, right? So there is an uncertainty while taking a decision. So in that case, there is a need that whatever you did in the sample, whatever analysis you did on the sample, you have to do it on the whole data set. Now when you have to do it in the whole data set, let's say 10 terabyte of data, let's say 10 terabyte of data are there, that is like 10,000 GB of data. If data size is that huge, you cannot a single machine cannot go and run on the data and do some analysis, right? Then you need to have multiple machines working together on that data set, right? So when there is uncertainty in the data, working on a small sample is not possible. You have to work on the whole set of data. In that case, again, big data ecosystem will be used, right? So when you will see all these 4 aspects, you should be sure that this is the time to use big data ecosystem instead of a single large server. Okay, so this is all about big data. This is some overview of how the big data should be used and where it should be used. Now let us try to understand what is business analytics. Okay, as we know, business is all about data, right? So business analytics is a person who uses the data, who looks at the data, use some information technology. Information technology means some kind of programming, maybe a business analytics guy can use Excel sheet also. A business analytics guy can use a SAS programming. A business analytics guy can use R programming, or some kind of information technology, and he should know a little bit of statistical analysis and some quantitative methods. And when I say statistical analysis, it's coming from maths, right? Should have a mathematical background and should use computer-based models. Computer-based models means some programming knowledge, and having all this, key knowledges, when a business guy works on a data to analyze the past business performance, or to analyze the past data, and infer something from the past data, then out of what he has informed, what he will do it if he can predict the future business trend. Okay, let's say I wanted to predict my future sales. Let's say I am a business analyst. I'm a business analytical guy inside Continental Airway, which runs in US. Continental Airway, and the executive has appointed me to work on the revenue of Continental Airlines. Okay, revenue of Continental Airlines. Now, as a business analyst, what I'll do is I'm going to ask, okay, tell me what are the sales or the sales revenue that has happened in the past few quarters of the year, and what is your air passenger average passenger per miles, like what is the average passenger in the flight, what is the fuel cost in the last quarters, in the last few quarters, what are the employee salary that you have invested for the last past quarters, and what is your profits that you have made. Okay, and what are the cost, what is the amount you are paying to the airport authority. Then it will also gonna ask like, okay, what is the GDP of that country on which we are working, right? For the past few quarters, what are the GDP of that country, what are the crude oil price of the of in that country, a lot many more other things, right? So by looking at all these things, we'll try to analyze, okay, what went wrong, why the Continental Airlines revenue was down in the past. And we may also wanted to get American Airlines. Let's say we know that American Airlines is working very good in the past, and their revenue is actually very good in the past, irrespective of the crude oil price being high, because oil price will be same for Continental, same for American Airlines, right? But American Airlines still performs good, still they make profit where Continental is making loss. So as a business analyst guy, we need to go and look into the data of both the companies and try to see, okay, what was the thing that American Airlines was doing so that it was making profit, but the same thing was not being done by Continental Airlines, which resulted in loss. Okay, so that's a job of doing analysis on the past business performance. Okay, you may single-handedly look into the past business performance of Continental Airlines on which you are working as a business analyst, or you can also compare to the competitors' performance. And inside is, after looking at, okay, what are the key components. Okay, employee salary given. Okay, what is the employee salary given, what is the employee satisfaction, what is the customer satisfaction in the past, what are the crude oil price, what is the air passenger, like what is the pax, like when we say pax means passenger per miles. Okay, basically it's like an average passenger traveling in a flight. Okay, by looking at all this, what is the average ticket price, what is the average ticket price. So by looking all this, if you can know that, okay, we can actually predict the future performance, future sales, then inside is like, can we say what will be my coming quarters revenue based on whatever is happening currently. So that is like insight. By when I say we'll have an insight into the data, that means we should be in a position to predict the future performances. Okay, so analyzing means analyzing the past performances. Insight means after analyzing which are the key components which drives my business, can I predict my future business performance. Okay, so a business analyst does all these things by knowing, by having the knowledge on data or statistical model or statistical analysis, some quantitative methods. Okay, and should be little knowledgeable on mathematics, and should be having a computer based models. When it's a computer based model, he should be having some knowledge on some programming. Okay, some programming skill. That is why we are introducing R also along with the business analytics course. So now, having, once you decide, once you do analysis, and once you do insight, what is the benefit of it? Now the executives in the business can go, and once you publish a report to the higher authority, they can go and be assured, and they can take an informed business decision, right? Because the higher authority has to take a business decision how they want to run their airline going forward. Okay, now because you have given them a report that, see, American Airlines has sometime reduce the ticket price so that the passenger per flight should increase, so that none of the seats should go vacant. Okay, if you just keep the price high, saying that we make a standard, right, we don't go low, we have a standard, it may happen that the GDP of the country is low, so that people tend to spend less on the air ticket. Them, and due to that, because of a high ticket price, some of the seats may go vacant. And then if more than 5 seats goes vacant, it may result to a loss to the company. So you should ensure that you should keep the ticket price low sometime, so that the seats gets occupied by customers, right? So probably that's kind of analysis will give to them, and based on your analysis, the business can take a decision, and the business can say that, okay, from the next quarter we will have some time slots on which will vary the ticket price, some light low to high. Okay, so that's how, even if you go and look at Indigo or any airlines, right, once you when you buy a ticket price, in the beginning it was low, and when it is towards the end of the traveling time, the ticket price goes high. Okay, so that is one way of doing business, by taking some informed business decision. Okay, so that is what a business analyst or business analytical person job is, and how, and this is where he will benefit the business. Okay, now, where all business analytics applications are important? Business analytics applications are important in many areas. I would say almost every areas where IT has pitched in, or where company is running based on analyzing past business performance. Okay, like email marketing, you send email to lots of person, right, saying that okay, you want to products and promotion. Even we sent you emails to join this webinar, right? So now, if we go ahead and send this webinar email to everybody in Bangalore, or everybody in Hyderabad or Delhi, everybody will not turn out to attend the webinar, right? So we have to be sure who are the candidates who will be interested in taking the course, or whose profile matches very close, or they are the best candidate to switch to business analytics course, and based on that we'll try to do the email marketing. In such way, in the same way, product promotion or the marketing guys also sends email, by analyzing the right guy to send the email, who will turn out, who will respond to that email. Then product promotion, healthcare. In the healthcare also it is important. Insurance, what should be the copay if somebody is already started filling a pseudo claim form and saying that he has an let's say he has an heart attack, and he has already gone through some test. What are the other likelihood tests, or other tests that he is most likely to go through, so that the insurance company in advance should be prepared, should be ready with what will be the copay, what is the amount that the patient should bear, and what is the amount that the insurance company has to bear. In advance, they need to be ready, right? So that there will be zero delay between the claim process, right? So similarly, supply chain management, we use business analytics. Human resource planning, how many employees we need to hire. Okay, what is my churn rate in my company, what will be my churn rate in the future, and how do I compensate by hiring fresh employees or lateral employees, right? Pricing decision, what should be the perfect pricing of the shoe that is being, let's say a Nike has is launching five shoes, okay, five new shoes, and Reebok, Puma, all these are competitors these days, right? And Adidas are competitors. So it should find a right pricing for the shoe so that it captures the market. So what should be the right pricing for those new launches so that it captures the market? So pricing, taking the pricing decision, there also business analytics will come. Okay, so there are many, I mean, all the applications in all the domains you can actually use business analytics. Okay, now how does business analytics helps in business is like it will be profitable, right? It will the increase the profitability of the business by, the obvious thing is by adding more revenue to the business, right? If the revenue increases, the shareholders who have invested in the company will start getting more shares, right? Or their return, their profit return will be high. And now, well, doing business analytics, not just the business analyst, everybody in the team, right? Who the business analyst reports, like all the top hierarchy people, executive, will start gaining more understanding on the data, right? When they start gaining more understanding on the data, for example, in the Continental Airlines, all the executives start understanding, okay, this was the problem that was happening in my past, and that is why I was making less profit. So compared to American Airlines. So now it will help them to remain competitive in the market, right? If you just work on your own data and do not look into your competitors' performance and try to understand why they are making profits or why they are making loss at the same time, I'm not making profit, or I'm making profit where they are making loss. What is the key difference? Where is the change that is actually impacting this profit or loss? If we can understand that, then it will help us remaining competitive and make better business in the competitive market, right? And it will also business analytics or business analysis will also helps you in creating informative reports. Like informative reports means not just discovery reports, but some patterns inside the data. What is the hidden pattern inside the data? If you can get that, that will help the business a lot. And also, the one of the main thing is, if you start doing this, it also increase the sentiment of the company, right? When I say sentiment of the company means, it will increase the customer faith on the company will also increase, because it understands where the things has gone wrong or where the things has gone right, and it will act accordingly. Then definitely customer will also appreciate the company, right? Or they appreciate the business, or the way in which the company runs its business, or the shareholders will also appreciate the effort of the company. So a business analytics guy plays a very crucial role these days in the company. Okay, and we'll see what is the trend, how much business analytics requirement is there in every company these days. Okay, so when I say analytics, so business analytics, right? Business is any person who is doing business. I am being recruited by the company to do business, to do some work so that the business gets improvised. So business means business should make profit. Analytics means you are the guy who will be doing analytics on the data. You are the guy who will be doing analytics on the data. Let's try to see on a broader perspective, what are the different kind of analytics possible on the data. So there are three different kind of analytics that can be possible in the data. We are not saying this is the three thumb rule of saying three different kind of analytics, but this is one way of dividing analytics. There will be many other ways of dividing analytics. Let's try to understand what are the three types. First one is descriptive analytics. Second one is predictive analytics. Third one is prescriptive analytics. Now, when I say descriptive analytics, means look at the past data and the present data and just describe the data. Okay, just describe the data. Predictive analytics means by looking at different attributes, like like air passenger per miles, the average price ticket, the oil price, right? The oil price, the airport charge in quarter in every quarter, or the GDP of the country in every quarter, right? But the crude oil price in every quarter. So by taking all this thing, if we understand that all this thing drives my total revenue, probably I can have a model which will take all this input data and which can predict my um, uh, revenue. Now try to understand how the GDP will behave in the next quarter. You can easily get that data from the government agency. What will be the crude oil price in the coming quarters? We can easily get it from the oil industry. They have a perfect way of predicting that. What will be the airport charges in the coming quarters? The airport authority would have definitely planned it to, okay, so you can get those things. And what will be the passenger average ticket price is your own thing, right? As a continental airline company, you'd decide that what will be my average ticket price, what are the ticket price I'll be keeping in the coming quarters. If you want to increase or decrease, you can take a decision on that, right? So you will get all those input data future values easily. Now the thing is, once you get the future input data values, only thing you have to take those input value, put it into a model, and predict what will be the revenue based on those input data values. So that is we call it as a predictive analytics. Okay. Whereas descriptive analytics is like, okay, how many quarters? What was the average profit for the whole 2015 year? Okay, whole 2015 year. What is the standard deviation? What is the variation in profit for the last 5 years? What is the trend of the oil price in the last 5 years? So all those things are descriptive analytics. Whereas predicting means to predict something by knowing some facts. If you can predict the sales revenue, or if you can predict the revenue of the company, that we call it as a predictive analytics. Now, prescriptive analytics, like, it will use some sorts of optimization technique. Okay, so use some optimization technique and suggest what should be done to optimize the result. Okay, now take the example of this. As a business analytical guy, you have told the business that, boss, you have to reduce the ticket price a little. You have to reduce the ticket price a little. Now, you are not saying how much reduction should happen, or you can say, okay, you may have to reduce the ticket price by $5 less, so that the people, because even $2 or $3 less change the people mind these days, right? People just shop. When you shop, even for a little price, they are ready to go to any other airlines, because buying a ticket is so easy these days. You go and log in to Make My Trip or any portal, and you can buy ticket from multiple airlines, right? So there is no point in hesitating for $2. You won't say that, okay, boss, this price ticket is less $2. I will still stick to continental airline. But 900 people out of 1,000 people will go with American Airlines because the price is $2 less. Okay, there might be 100 people who still don't care or carefree about the ticket price, but 90% people will be careful about the ticket price. Now, if you say the business, okay, you have to make the ticket price less by $5, but the business has to take, okay, exactly what should be my amount on which I should sell the ticket price, or should I keep the ticket price low in the beginning and end high towards the end, or should I go with a flat ticket price for the full month? Okay, for the full month, or what would be my exact pricing? What should be my exact pricing, and how I should uh, price the ticket throughout the month time, right? So that is the kind of decision the business has to take, and that is where the optimization model will come into picture, and it will tell you, okay, this is the way you should price your ticket, or you can put a high price towards the beginning, maybe low price towards the end, and do not keep high price towards the end. Keep some little low price towards the end, because we see these days a lot of aircraft are going empty seats, are going few seats as empty. So there will be a competition towards the end, towards the last minute flight ticket sale. So instead of very high price, let us keep the price little low so that uh, let us keep the price little low compared to our competitors so that people starts coming to our airlines and buy tickets. Okay, so probably that kind of method you can apply, and that will come from a term called prescriptive analytics. Okay, now let us look at another example. A retail store, a retail store. Let's take the retail store of a hypercity. Let's take a retail store of a hypercity or a Reliance Smart. Okay, let's say Reliance Smart want to run a clearance sale by reducing the prices. Okay, by reducing the prices so that it finishes its inventory which is about to expire. This is about to expire. Now the right question is, when should we reduce the price and by how much? Should it go and reduce the price by 50% at the beginning and start putting the items on the shelf saying that okay 50% sell, or should I go with 20% discount in the beginning, then next week 30%, and so on and so forth, and I can end with 50%? Should I go like this, or should I use some other mechanism? Okay, so now what will the three analytics that we talk, like descriptive, predictive, and prescriptive, how these three analytics will help me? Let us try to see that. So descriptive analytics will only see what is the past historical data and what was the pricing in the past and how much units I sold in the past per day. So that is all descriptive analytics will do. Now, predictive analytics will say that okay, if I decrease my price by giving a 10% discount, how much my sale will be, because it knows well, by looking at the past pricing data and its sales data, it can actually build a prediction model, and based on a new pricing, it can actually tell you what should be, how much sale it will generate. Okay, how many units will be sold. So predictive analytics will do that. So it will have a model which can predict the sales based on a pricing. Now prescriptive analytics will say that what should be my best set of pricing. Every low pricing will not work, right? There will be some set of pricing within certain range of the pricing. Your sale, you may see that the sale is very high. Even if you decrease beyond that, if you decrease beyond that, your sale may not go low. You may see that okay, if I keep my discount between 30 to 60%, it is working very nice. My sales is going high. Sales are shoot up. But if I go below 60% to 70, 75, 80%, I don't see any improvement in the sale, because it may happen that people start having a doubt. Hey, this product may be very bad in quality, or it is coming to the expiry, and near to expiry may be very bad for health, or this may not be a good product compared to its competitor. That is why it is giving lots of discount. So if the discount is also very less, right, people starts having doubt. So you may not increase your sales that much. So there has to be a right pricing. Has to be a right discount. Okay, and that is the job of a prescriptive analytics. What should be my right discount, and when I should phase out the discount? Should I keep on increasing my discount, or should I keep my discount flat for the whole period of this sale that is happening, right? So that is how the descriptive, predictive, and prescriptive analytics works in a domain. Okay, now as we are talking about analytics, you might be hearing that earlier you might be hearing business intelligence, right? Many of the company will have a group says that we work on BI, we work on BI, DWBI, data warehousing and business intelligence. Data warehousing is how you arrange the data, or how do you slice and dice the data, right? So that is data. You use OLAP, you use something else for storing the data. That's all data warehousing. But BI means business intelligence. Say we have 100 guys who are expert in BI, right? So you will get a lot of BI guys in the industry. Now let us try to compare BI guys with a business analytics guy. How these two guys will be different from each other. Two guys are close to each other, but what makes business analytics different from business intelligence? Okay, let's say you are looking at sales. Let's say you are looking at sales of uh, of 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 a particular product. Let's say sales of Microsoft Windows platform. Let's say Mike, you are a business. There is a guy who works on BI domain in Microsoft company, and you are a guy who works in business analytics domain for Microsoft industry. And Microsoft has launched Windows 10. It wants to analyze the performance of Windows 10 sales. Okay, you wanted to analyze the performance of sales of new operating system, that is Windows 10. As a business and intelligence BI guy, what you will do is, what happened in the last quarter? You will go and ask yourself questions based on the data. What happened in the last quarter? How many units being sold? Okay, what is the problem? What is the problem? Which area? In which country my sales was low? In which country my sales was high? Was the last quarter performance was better than the previous quarter performance in the same year, or same quarter in the last year? Let's say you are working on Q4 of 2015. You are looking at the Q4 of 2015. That's the last quarter, right? Quarter 4 of 2015, the last 3 months. Whether the quarter 4 of last 2015 we made a profit compared to Q3 of 2015, you will ask that question. Or you will again ask the question whether we made a profit in Q4 of 2015 compared to Q4 of 2014 of the last same quarter of the last year. So those kind of questions we're gonna ask, right? But a business analytics guy will ask, okay, what if I reduce my Windows 10 price little lower, on which where the, okay, as a BI guy you will say that, okay, in India the sale is very low, probably people are going for pirated Windows compared to per key based Windows, right? In India our IT rules are not very strong, right? You can download torrents and install, right? But in US and any other country it's very strict. Okay, so you have to use operating system, it has to be licensed version. So to attract customer, you may come out with some analysis. Okay, if I reduce my Windows 10 price from 10,000 rupees to 9,000 rupees, how much sales I will generate in India? Okay, that is a kind of question a business analytics guy will ask himself and try to do that. What will be the optimal scenario of our business? Okay, what will be the optimal scenario of our business now? Right, should we go for should we give individual license, or we can say that, okay, one Windows can be used by 5 people, but paying instead of 10,000, if you pay us 30,000, 5 people can use the Windows simultaneously. Some kind of optimal scenario on which you will make profit. Okay, so that's a business analytics guy will try to answer. It will also answer, okay, looking at the current trend, what will be the future Q1 2016 sales in India, or what will be the sales in the next coming 4 quarters in India? What will be my sales? Am I making profit? Am I making more sales, or am I making less sales in coming quarters? Okay, that is the question the business analytics guy will ask, right? So if you look at here, the timeline, look at the time on the x-axis, past to future, and the y-axis, the analytical approach. It goes from explanatory to exploratory. Explain means whatever is explicitly in the data, just explain it. Exploratory means the information are hidden inside the data, and you're going to explore. You have to mine the data, you have to explore those hidden information. So business analytics is more about working on the future trends and exploring the data, whereas BI guys just look at the current and the past data, and it explains the data in a better way. It will try to explain the data, or it will try to summarize the data, whereas a business analytics guy will also predict the future, will also try to explore few hidden facts inside the data. Okay, that is the difference between a business analytics person or a BI person in industry. Okay, do I have any questions? No. Okay. Okay, now let us say, as a business analytics expert in the industry, where do we sit? What are the different level at which the data are being captured or data are stored in the industry? Okay, on an abstract level, we can divide the storing and usage of the data into four different levels. The first level is the data devices, which captures the data, right? So what are the data devices in the current world which captures the data? Your computer, your cell phone, you have a GPS enabled in your car, so a GPS. So you have bought it from some company, right? So that company will also have storing the GPS data for sure, on which route you are traveling, how much time your car is taking when it travels a route, travels on it. So a GPS will work. When you open Google Map and use a GPS system to follow the Google Map from going from, let's say, uh, going from New Delhi to Noida during a daytime in the Monday, the Google company itself stores the data, how much time you take, and what is the average speed. So from that, it actually computes how much crowd is there in the particular time on Monday from the route from New Delhi to Noida. Okay, so GPS data captures the data, MP3 player captures the data, ebook, YouTube, credit card holder. When you swipe your credit card, there are the data is being generated, your transaction is being captured. When you are using an ATM, your transaction are being captured. Video surveillance, right? Every government has this, just put camera everywhere, right? CCTV camera on the traffic signal, so it try to capture the traffic, how much volume of traffic is there today's and every day in a particular duration. So data is everywhere, even medical imaging, right? Whenever you take X-ray reports, you take ultrasound reports, you take MRI reports, and also many people take MRI reports, many people take X-ray reports. So which are the X-ray are matching? So if your MRI reports matches to a person who has having a disease and the MRI reports are same, probably you might be having the same disease, right? That's the experience that doctor gains, right? When the doctor looks at past patients, it gains knowledge, right? Based on the past patients' behavior, their symptoms, and all. The doctor has learned over the course, and he has become an expert in the medical domain. And when you go and say that, okay, I'm sneezing, I have a little temperature, and my nose is running, probably you might be having a pneumonia or something, and you are having a high fever, and that is a pattern that has happened in the past, and most of the patient who has complained, 90% of them are having pneumonia. Probably you might be having a pneumonia. Go and do some blood test reports or something, right? So there are many ways data are being captured, right? So if I capture all those medical images and all, and I can use a modeling which will actually captures the way the doctors are gaining the knowledge. If I can have a computer based system which will do that, that will benefit, right? I can automate a lot of process, right? I'm not saying that we'll completely remove all the doctor from the industry and machines will start giving prescription and all. That will never gonna happen. We need human being, but it will assist the new doctors, right? It will assist the new doctors who are in the field to get the same expert knowledge which the old doctors are having from a machine. Okay, I got a question. How data mining is different from big data? Data mining is about mining the data. Data mining is about mining the data to say that what will be the attrition, what will be the right pricing, what will okay, which kind of customers are likely to buy new products. So that is all about data mining. Whereas big data is a ecosystem which saves the data. Big data is an ecosystem which saves the data, and data mining is a domain, or you are an analyst. You will be using data mining to mine on the data sitting inside the big data ecosystem to get some knowledge out of it. Okay, so we generate pattern and trends like we do in big data. Yes. So data mining guy can work on a small data, or it can work on a big data, right? So it's all about, so whether if you are working on a big data, like a huge amount of data,
So data mining is applied on a big data. Okay, so big data is a data ecosystem, whereas data mining is a art to work on a data. Did I answer your question? Machine learning. Uh, Machine learning, I'll explain a little later. Okay, machine learning, I'll explain a little later. It's coming on the slides. As I said, data mining is an art, or a data mining is a way to, or a art to work on a data to find hidden patterns, to find interesting patterns inside the data and use that to improve the business. That is all data mining. Whereas big data is a ecosystem or a technology to store the data, to store huge amount of data. It does nothing other than storing the data in a perfect way. But data mining is working on the data, okay, working on that data intelligently to find the meaningful answers or find the hidden patterns, find interesting patterns inside the data and use it for improving business. Okay, machine learning will come shortly onto that. Hold on that question for a little while. So now, so the first layer is we the devices which captures the data. The second layer is which are the organization who captures the data. So government organization captures the data, medical organization you captures the data by medical imaging devices. Internet captures the data, what are the kind of browsing you are doing. Retail market captures the data, what how much sales they are happening, right? When credit card when card swipes and all, when you do card swipes, when you do ATM swipes and all, then financial companies like financial industry like banks and all, they captures your data. When you call a person, when you do text messaging, right, then phone industry will capture your data. So there will be many industry will capture the data, so they captures the data. Then the third layer is a data aggregator. The company may themselves try to store the data, try to organize the data, but sometimes the company is out of resource. They hire a third party, some vendors who are called data aggregators, which will organize the data, who will organize the data and will give them some elementary reports like this is the data amount coming every day, this is your whole data size, these are the these are the attributes that we have stored inside the databases for you. So all those kind of report will be given by the data aggregator level. Okay, the third party vendor to the primary organization who are capturing the data. Now the fourth layer is the data user or the data buyer. Now the data user will be those company who have generated the data, the government, the medical organization, or somebody. uh, and so they will take the data and start working on it, and there will be some company who will work as a data buyer because they wanted to know, let's say um, ICC bank wanted to know how HSBC, how SDFC, how SBI are doing business. I wanted to know their business model, right? I wanted to know how much customer they have, how much transaction it is making. I wanted to know a little bit deep about their business, how they are doing business. So where do we does it get data? It has to buy the data from the data aggregator. Okay, probably the data aggregator will have a will have a business agreement with I say with those banks, where banks will say that okay, you can sell some of the data by some giving some taking some price, and you have to share the pricing profit with us, but you cannot sell some of the proprietary data to my business. Okay, because if it restricts the data aggregator to sell the data to other banks, the ICICI bank itself will not get the SDFC bank will not get ICC data, and ICICI bank will never get SDFC data. So they cannot do competitive business, right? Everybody has to work on silo, and that will not profit any bank, right? So there has to be a common agreement that these are the data which we can share among each other, right? So there will be data user and data buyer. Now is a business analytics expert, you would be lying somewhere in the data aggregator companies, data aggregator companies, or the fourth layer, data user or data buyer companies. Okay, the company which buys data will wanted to do analysis on the data. The company who uses its own data from the data aggregator will do analysis on the data. It will definitely sit on the fourth layer. So whichever company sit on the fourth layer, you can be a right employee for those companies, or whichever companies even sits on the third layer, aggregates the data. They have to give some kind of reporting to the company, for the company who's it is storing the data. For that example, let's take Bloomberg. Bloomberg stores financial data. Bloomberg aggregate financial data of most of the company. Dow Jones. Dow Jones stores financial data of lots of companies, right? So they are data aggregator. Now you'll definitely get a job in those kind of company if you are a business analytics expert. Okay, so your area to target is a layer third and layer fourth, data aggregator layer and data user and buyer layer. Okay. Okay, I have some more questions. Let me see the question. I'm not able to see the questions of other people. You cannot see the questions of other people. Only I can see. Okay, but I'll read out those questions. I'll read out those questions clearly before I answer those questions. Okay. So one question which is unanswered is, what is machine learning? What is it related to? We'll answer that shortly here in this particular slide. Okay. Now we have known what is business analyst, what is a business analyst, who does analytics, right, and how it is useful, which of the industry, which kind of industry will be, you will get a job. So we have seen all this, right, and how it improves the business, everything we have seen. What are the different kind of statistics you can use, or what is the different kind of analytics you can use? You use of descriptive, predictive, and prescriptives. Now let us go into a broader subject called data science. Okay, what is data science? Yeah, somebody has asked, Anand has asked, can you tell something about R and other tools? We'll come to that shortly. Just hold your question. Everything will be covered within next 30 minutes or next 20 minutes even. So let's talk about data science. Okay, data science. So when you say you are a business analytical person, or you are doing business analytics, you are a part of data science. Okay, now data science is a broader subject, data science is an interdisciplinary subject. When I say interdisciplinary subject, means it's a it's a course having multiple subjects inside it, right? It's an interdisciplinary subjects, which is study of a field about processing data in various forms, either structured or unstructured. When I say structured, means tabular format, right? Excel data or anything. Unstructured means text data or videos. Let's say you are watching traffic data. When I say traffic data, only a camera is being installed on the traffic signal, and it just take a video of all the traffics. Now you have to go and ask, like, what is the traffic density from the video image. From the video you have to find the traffic density, right? What you can do is you can take frames after frame, and every time, after every second, what is the frame density you have to compute. So right, so that means the data, most of the time the data are unstructured. In the real world, 70% of the data are unstructured, and only 30% of the data are structured, where you will get in a nice tabular format. Okay, so a data science is an interdisciplinary field about processes and system. So it's about, like, what is the process and what kind of system I should use to extract knowledge or insight from data. Okay, it's all about extracting knowledge and insight from the data. And the data can be of various forms, like structured or unstructured. Okay, so data science. Okay, now let's see what are the different components of data science. So data science is a continuation of some of the data analysis field. So what are the data analysis field? Statistics, data mining. Data mining means some algorithm. Okay, data mining, just assume it to be some algorithm, some complex algorithm, using which you can learn some pattern inside the data. Predictive analytics means predictive modeling, doing forecasting, doing regressions and all that are all called predictive analytics, right? So data science is a continuation of this kind of fields. So if you look at the diagram, in the middle, if you see in the middle, you see data science, right? So to become a data to learn the data science field, you have to know all these things. You have to know statistics for sure. And before even knowing statistics, you wanted to apply data science into a particular field. Let's say you want to apply data science on banking industry. If you do not know how banking industry works, how credit card works, how credit card, how banks makes profit from the credit card, why does we give additional days, uh, 20 days extra to pay the bill, what are the rates on which we apply, when you withdraw cash, what's the interest rate we apply, when you default, what the interest rate we apply, can we, at what criteria we can uh, we can we can exempt customer from giving interest rates. So if you do not know all this operating criteria, or that means if you do not know the domain knowledge about the bank, you cannot work on the data, right? So having the domain knowledge is the first and primary thing that you need to know. Okay, as a data science guy, you may ask some domain expert inside the industry to give you the domain knowledge, but you should have the right mind, a flexible mind to acquire that domain knowledge, right, over the period of time. So domain knowledge is the first and primary important thing in the data science field. Then you should know a little bit maths, right? When I say maths means you should know statistics. You have to know statistics. Then database technology, you should know database technology. The data can be of various format. Data can be stored in various databases. Data can be flat files. Data can be Excel file. Data can be Word files, Word report. Data can be stored in Oracle. Data can be stored in MySQL. Data can be stored inside Hadoop also. So you as a data science, if you work in a data science, see, data science is not just one guy. It should be a team. It should be a team which will hand to hand, by coordinating all the team members. Everybody will work in the data science field, right? So there should be some persons will be working on the database technology to import all the data, and so that the data science guy can work on this data. And even the data science guy should have little bit knowledge on the database technology, how the data is being faced, how, what are the columns I should be needing. I should need to analyze the data. So database technology, like knowing some SQL programming, or even to know how to export a Excel file into your domain or into your environment. You should know that. That's okay. So database technology is important. Some programming skill, if you know Java, C Sharp, or anything, Python, everything is fine. So for the programming skill, for having that programming skill, we are introducing R here, right? So R is a programming skill that you need to know to work on data science field. Then visualization, whatever you have learned, whatever pattern you have learned, whatever facts that you have learned as a data analyst or a business analyst in data science domain, you have to make a report out of it, right? You have to make a report out of it. Now, if you make a Word file, if you make a Word file and write just lines and lines and lines and give it to the executive will just throw it out. Will say this is not useful. I don't have time to read your 10-page document. I don't have time to read your 10-page document. This is crap. I am not going to read it. Although you might have written very strong facts about the business, but the business guy will not read it a simple Word files. Okay. So instead of that, if you build a very nice visualization, you draw some charts, you show some histogram, you show some fields, build some pie charts, right? Pie charts like pizza and all. So you make it little beautiful, and in one page all the information are captured. Then a executive will definitely try to look, he will be interested in looking at this kind of reporting. So a visual reporting is 10 times effective than a word based reporting, right? So you have to know what kind of visualization you should be using. So like these days, Tableau, Quick View, these are all the visualization tool which you can use to make reports, right? Then comes to the last category is machine learning. So when I say machine learning algorithms, machine learning are these are the part of artificial intelligence, and this will have a set of algorithms where you can do something like attrition analysis or churn analysis. If you want to look churn analysis, you can do churn analysis, you can do forecasting, you can do forecasting, okay, you can do customer grouping, like in a bank, which are the customers which are very similar to each other, okay, which are the customer which are very similar to each other. So you will have okay, let me erase all this. I'll have some space to draw a little uh, something else. Okay. Now in a bank, you may have 1 million customers. Not 1 million customers are same in nature, right? So what we'll do is, okay, let me find 10 groups of customers, 10 group of customers. So I'm going to find 10 groups of customers where inside each of the group, all the customers are similar in nature. But when you take one customer here, and one customer in the group two, that is, this is group one and this is group two. If you compare two customers across two groups, this customer will be very different from each other. But you compare two customers within the group, their property will be very similar to each other. So how will gonna benefit from this? Now, one scenario is like this. Let's say this guy buys a credit card, a platinum credit card, goes for a platinum credit card, and these two guys' salary are very equal, their age group are equal, they belong to same IT industry, right? And they stays both the guys stays in Bangalore, let's say. And in that case, probably because there are lots of matching in these two guys. So if this guy goes for a platinum credit card, probably the bank will approach this guy and say, "Sir, you are using a silver credit card. You can, looking at your current profile, we think you can rightly afford a platinum credit card, and platinum credit card will give you lots of benefits." And the bank knows that there is a similar guy who is using platinum credit card, so this guy is more likely to say yes to platinum credit card. Okay, that is where this grouping works, and we call it as clustering. Okay, so clustering, churn analysis. When you do churn analysis, which are the customers who may likely to go out of my bank, that is churn analysis. We use something called classification. When you go to Amazon site and buy a laptop, when you go to Amazon site and buy a laptop, you also see Amazon listing out, okay, you can buy a laptop scheme, you can buy a wireless mouse, you can even buy a external hard disk. So people who buys laptop also buys this combinedly. Amazon shows this kind of advertisement, right? Just below the page. Just if you scroll down the main sale page, you will see this kind of advertisement at the combined price. So like this is this is says cross selling. We do cross selling. We call it cross selling, like selling extra products with the primary product is called cross selling, right? And this we call say recommendation. This is recommendation engine. So Amazon uses recommendation engine, and this particular algorithm is called association rule mining. Association rule mining. So clustering, classification, association rule mining, forecasting, forecasting, forecasting next tomorrow stock market. What is the average stock? What is the stock market value of BAC for the next 1 week? If you can forecast that, that will be good, right? That will be good for the people who wanted to invest in BSc. So forecasting is one. Regression. What will be tomorrow electric consumption in whole Mumbai city based on tomorrow was predicted rainfall, tomorrow's temperature, and tomorrow's humidity. That is regression. Okay. So classification, clustering, association rule mining, forecasting, regression, these are all part of machine learning algorithm. Okay, these are all part of machine learning algorithms. There are many more advanced technique also is a part of the machine learning algorithm, but these are the key components of machine learning algorithms. Did I answer the question of what is machine learning algorithm? Okay, do you have any more questions coming in? Yeah, about R, what is R, why you should use R compared to any other question, we'll talk shortly. Okay, now as a part of business analytics course, we will be covering statistics in length and breadth. We will be covering a programming skill. We will be telling very depth about R, and whenever we'll solve some use cases, we'll be covering something about detail about that particular domain, how the retail industry works. Or if we solve a use cases about bank, we'll be telling about how the bank domain works, how the bank works. Okay, so cross sale is, I got a question. What is cross selling? Cross selling is if you are buying a car, if you are buying a car to the the company, right? Let's say you are buying a Hyundai, you are buying a Hyundai Verna car, and you have gone to a Hyundai car shop floor. The salesperson says that, sir, we have a tie up with Bajaj Allianz because Bajaj Allianz is the best and gives best insurance. So we have a right tie up with. We can give you the insurance in just 5 minutes. Would you like to go with the insurance? So the salesperson is trying to sell Bajaj Allianz insurance along with the Verna car. So you are primarily gone for buying the Verna car, but along with that, you thought that I'll be buying the insurance leisurely by looking at the internet and all, by looking at multiple, but the salesperson was successful in making you buy the Bajaj Allianz insurance along with the car. So the salesperson has done a cross selling. You went for a car, along with that you went ahead and bought the Bajaj Allianz insurance, right? That is cross selling. By like buying, you went for a primary product, but you went ahead and bought some other product along with it. That is called cross selling. Okay, but there is something called upselling. You went for a Grand i10 car. You thought that I'll be buying a Grand i10 car, but when the salesperson went ahead and see some, uh, you went for, let's say you wanted to go for a loan, so you went and gave the salary 16 form, some bank statement. Looking at the bank statement, the salesperson knows that, hey, this guy can actually afford a Verna car. It tried to make a lucrative offer. Sir, we'll give you 60,000 discount if you buy Verna car, and your salary is high, sir. You can buy Verna car. Many people of your salary are buying a Verna car, sir. Why don't you buy a Verna car? Now you are a status conscious guy. Say, hey, people who are learning 15 lakhs per annum are buying a Verna car. Why should not I go and buy a Verna car? So you went for a Grand i10, but you went ahead and bought a Verna car, right? So that is a upselling. Going for a better product is upselling. But buying, you went for a car but bought a insurance along with it, that is called cross selling. Okay, I got another question. What is R? Is R like Tableau? What is the so what is the best part R compares to Tableau? Who's to choose R instead of Tableau? Oh, hold on. So you are asking about a comparison between R and Tableau. I'll come to that. Let me first come to what is R and who should be using R, how it is different from other language. Let me come to that question. So okay, so right now we know what are the different components of data science, right? And these are the three aspects we'll be telling you. Apart from that three aspects, we'll be going through subjects like regression. We'll be going through subjects like logistic regression, which is a part of classification algorithm. So we'll be covering little portion of machine learning algorithm also inside the business analytics course. Will not be covering database technology, but what we'll be giving you is we'll be giving you knowledge. Let's say if your data is inside MySQL, if you want to bring it to inside our environment, how would you bring it inside our environment? We'll be giving that knowledge to you. Okay. Machine learning, like I would say 20% of the learning algorithm will be covering inside this course. Visualization is not a part of this course, okay? But time to time, if you have any doubt, what kind of visualization you should be using, how the tableau will be used, I'll be answering all those questions. Okay, now let us see. As I said, for the having that programming skills, we'll be telling you about R, right? So why R? What is R? R is a programming language. R is a very simple programming language, okay, and it is mainly used by statistician or mathematician or data miners, okay, or data mining guys or a machine learning guys. R is a programming language widely used by statistician, mathematician, or data mining or machine learning guys. Data mining and machine learning are nothing but the same thing. Somebody says data mining, somebody says machine learning. But on an overall perspective, data mining is equal to machine learning. Both are same thing. Okay. Now, so as I see, R language is a very commonly used language, popular across statistician and data miners. Now, it is mainly used for mathematical or statistical computation. Okay, R programming is a language which is mainly used for statistical computing or building data mining models. Data mining models. Now, R has actually the main language when it started, we used to call it S language, like Java, C language, C++, right? Python. The language was called S language. The main language is called S language. The way you will write codes and all that, we call it S language. Now that S has been transformed into R when we use the S language for mostly for statistics and building mathematical models, building data mining model. It has been termed as R language, and it has been, there is a foundation called R Foundation for Statistical Computing. This is a foundation which has established this R language, and you will see CRAN site. There is a site called cran.org. Inside CRAN site, you will get all the packages, all the R installation, everything you'll see inside the CRAN site. Okay, so R is a programming language mainly used by statisticians and data miners. And why R is famous? Because there is more than 5,000 libraries. There are more than 5,000 libraries which has been already built by mathematicians and data miners, which is already built by mathematician data miners, are freely available, on the internet, are freely available on the screen side. You can just make use of those packages and do your task. You don't need to write any code from the scratch. Okay, you don't. If you want to build a linear regression, if you want to build a linear regression, you don't want to, there is a theory behind linear regression, how to build a linear regression model, how to find the optimal parameters and all. But if you say, okay, do I need to code everything? No, answer is no. You don't need to code everything. Only thing that you have to use a package called stats. You have to use a package called stats. Just use that package and just call a function called LM for linear model, and just say what are the input variables and output variables, and this LM will build a linear regression for you. As simple as that. Only thing is that you need to know the theory behind linear regression to interpret the result. Okay, R is such simple. Why R is simple? Because there are more than 5,000 open source packages available which you can download and use it for free. Okay, so R is a strong package ecosystem of having more than 5,000 packages. And R is very good for drawing charts. So you can use Tableau, you can use Quick View, but you can also do the same thing using R. You can also do the same thing. You can draw histogram, you can do pie charts, you can do time series chart, you can do line charts, okay, you can do scatter plots and everything. Then you can, if you want, you can actually convert the charts into a PDF file, and you can submit that report to your executive. It is that simple in R. You can easily draw lots of visualization in R. Okay, so R, instead of Tableau, you can also draw lots of visualization and lots of charts inside R itself. Okay. Now, if you say why R, why not Java, why not C, or why not Python, I would say R is a very simple language. Anybody can learn. Anybody can learn. Whereas Java, C, or C Sharp, or Python, you have to know OOPS concept. You have to know structure programming, and also you have to learn lots of programming skills to actually start getting your hands dirty into Java, C++, C Sharp, and all the languages. Whereas R, it is very easy to learn. Okay, very easy to learn. In the day one, you can start coding. You can do day one. It will be so easy that you can start coding, and you can build a regression model in a day one itself. Whereas for Java, you have to learn the whole book. You have to take a course in Java to be proficient in coding Java, right? So R is not just for advanced programmer; is for very amateur guys. Anybody can use R. Even I would say R is not for programmers. R is not for programmers. R is for mainly why R is famous, because statisticians use R. When you learn statistics in your 12th, or if you have a MS degree in statistics, or if you have a bachelor's degree in statistics, earlier, they even don't know anything about formulas. They don't know anything about formulas. So those guys also can learn R. That means R is not for programmers at all. It's for anybody who want to learn analytics. Anybody who want to learn analytics or learn statistics, they can, or learn data mining, they can go and do it using R. Okay. So you just have to have a eagerness, or have to have a grasping knowledge of learning data oriented models. If you learn data oriented models, or if you understand data oriented problems, you can use that R to code everything that you want. Okay. Now this is all about R. R is such simple. Now the question is how R is different from Tableau. Say Tableau is a reporting tool. Tableau is a reporting tool, whereas R is a modeling tool. R is a modeling tool. You can go and do linear regression. You can go and do churn analysis. You can do classification. You can do build a recommendation engine inside R. Okay, but you cannot do the same thing in Tableau. Giving some data, you can show nice reports in Tableau. Giving some data, you can show nice reports in Tableau, nice report in quick view. Okay. I mean, R will have something like R will have a forecasting model fitted integrated inside it, but it will not have everything, all the capabilities of R inside it. Okay, but R can build models. R can also build nice visualization and charts, whereas Tableau is only limited to creating reports and visualizations. Okay, so there is a very strong difference between R and Tableau. If you are asking me what is the difference between R and Tableau, there is a very thick line difference between R and Tableau. But in today's in today's world, you can actually integrate R and Tableau. Let's say you want to have a functionality. If you want to have a statistical functionality inside Tableau, actually you can call a R program. You can call a R program. You can integrate R environment with Tableau, and you can call a R program, and R program will give you that result. You can display that result in the Tableau. So integration of R and Tableau is possible. Okay, but integration of R and Tableau has not become very advanced. Slowly, Tableau is trying to get its hand dirty on try to make those R integration more strong, but it is evolving. But there is definitely a scope of integrating R and Tableau together. Somebody says, I get R is simple. Can it be used for very complicated advanced level of programming? Yes, it can be used for advanced level of programming. If you wanted to write nice way of structured programming, you wanted to write nice functions, a lot of you wanted to create function and use that function in many other programs, you can use that. So R is not, I said R is not just for advanced programmer. That doesn't mean that R is not for an advanced programmer. R can be used by any expertise level. As an amateur guy, you can also use R. As an expert programmer, also expert programmer can also use R. You can make the R programming structured way. So through the course, you will see how I am writing a small dirty script and do the same thing, and how I convert that dirty script into very structured way of writing program inside R. So you can choose both. If you are not comfortable in writing advanced program, you can choose to write small simple scripts and you can do the task. Both are possible. Okay. Now let us look at some companies who are using R these days. Okay, let us look at some companies who are using R these days. Look at these are few companies, few of the very renowned companies who are using R these days. New York Times use R, okay, to print to use interactive and print some visualization. Google, there are 500 more than when this result was faced 500. Probably now this time there will be more than 2,000, 2,500 employees who are working on R. And Google doesn't believe in having millions of employees in the company, right? Or lakhs of employees. Google is big company, but with limited number of employees. So FDA is a is a authority, or is it food department, food and drugs authority in US. So they use R to conduct some clinical trials on new drugs and new food. Okay, so FDA also use drug. John Deere is a tractor company. It's a tractor company. It manufactures tractors, and it manufactures uh, agriculture related machineries. So even John Deere also use R to optimize their tractors manufacturing process. Twitter uses R to R. Facebook also use R to model users' behavior. Foursquare is a company, very renowned company, is also used to develop recommendation engine. Okay, so there are many companies who are using R these days. So so scope of learning R and getting a job is also very wide. Okay, there is a huge scope of R. Okay, now let us look at some of the market demands. Okay, so this is a market demand which was published by McKinsey in 2011 of May. In 2011, 5 years down the line, McKinsey published a report saying that the market demand of business analytics. So this is all the jobs which is related to data. This is all the jobs related to data. So for the last layer, technology and data enablers like database guys, DBAs, database guys, or SaaS guys, right? SaaS guys, or all those things who creates data, stores the data. That is the last one. So that where as a business analytical person or a business analyst or a data scientist going forward, you wanted to be a data scientist 5 years down the line, right? It's because it's a huge paid job. Like uh, a 5 years experienced data scientist in US gets somewhere between 200K to 300K, which is huge. It is even more than a vice president in a bank. Okay, that's the demand of a data scientist. Business analyst gets somewhere between 100K to 200K. So that is also very huge, right? So the third, you would definitely not wanted to lie between the third layer, but look at the second and the third, like the top layer and the second layer. Data service professionals. Data service professionals are like data engineers who converts the data into some other format and all. Okay, so that is and business analyst lies somewhere between these two layers. Business analyst would lie somewhere between these two layers. They will sit somewhere between these two layers. They'll have the data savvy professional knowledge. They will have the deep analytical knowledge also. Mixture of this, not deeply into this, but a mixture of these two. So the projected US demand in 2018 is 1.5 billion jobs will be there for data savvy professionals, and there will be 140K to 190K, almost like 2 lakhs job will be for data scientists. This is a gap, means this going at the current hiring trend, there will be a gap of this many talents in this area. That means that suggests that there is a huge market demand that is coming in next 2 to 3 years for this knowledge. So if you are a business analyst, if you are a BA guy, business analyst, not BI, BA guy, you are sitting somewhere between these two. So Just you can calculate your figure, what will be the demand or what will be the gap in US in coming 2 to 3 years. Okay, there is a huge gap that will be coming. So there is a chance that you'll get a very nice job, maybe in India or maybe in abroad. Okay, going forward. We are not trying to lower you. We are not trying to give you a lucrative offer, but that is the fact that we are trying to tell you. And this fact has been published by McKinsey way back in May 2011. Okay, let us try to see some other marketing trend. Okay, now if you ask me why this marketing trend is so huge, if you say why this is so huge, this is why this was so huge. In 1990, the data, when we say electronic data, data was with companies like Oracle or SAP, they used to maintain data, right? Oracle and SAP, those are very key market players in the industry in 1990s, right? So RDBMS or data warehousing was into business, right? When the data, the whole data was in terms of some terabytes. The whole industry data was in terms of terabytes. These days, your laptop hard disk has 1 terabyte of data, right? But in 1990s, the whole data in the whole industry was in terabytes. Now, when we went to Millennium 2000s, the data are like PDF reports, Excel report, PPTs, Microsoft PowerPoints, uh, again databases, many more databases, MySQLs, all those sorts of databases are coming into picture. Now data are in terms of petabytes. So 1 petabyte is 100,000 terabytes. Right? Now when you went to 2010, right? Now we are in the era of 2010s, right? 2016. Now NoSQL concept came, Cassandra, right? Cassandra, JDIS, uh, Neo4j, lots of NoSQL databases has come into picture. YouTube, Facebook, Twitters are capturing market by producing huge amount of data. So now the data are in terms of exabyte. Now exabyte is 1,000 petabytes. So 1 exabyte is 10 to the power 6 GB, which is huge in nature, right? And going forward, it will become data byte. So data, the rate at which the data is growing is very, very high. Exponentially, data is growing, but the company is finding it's very hard to analyze the data. That means they need more resource who can analyze the data. So when I say resource, mean they need data scientists, business analysts who can work on the data and find some meaningful information. That is why the trend of job trend is exponential in nature these days. I got another question. Is data analyst, data scientist course is same? Where is the best place to learn, complete the course in the better future? Yeah, we are offering both the courses. We are offering both the courses, but this today's webinar is for business analyst. So let me go back and so data business analyst. See, business analyst. Well, hold on a second. Let me answer this question. Business analyst, like knowing statistics plus little bit of math related to statistics, some machine learning algorithms, and let's say R. If you learn this, you become a business analyst. Okay, business analyst. You become a BA. Now, data scientist, if you say data scientist, as on when you grow more and more in machine learning, start acquiring more machine learning algorithms, because this machine learning, knowing more about more machine learning algorithm only comes from practice and only comes from reading further and further. If you start acquiring more and more machine learning knowledge, you will become a data scientist. So it's over the course. You will transition from business analyst to a data scientist over the course. Okay, if you join as a business analyst over the course of 5 years, I would definitely say yes. Over the course of 5 years, if you start practicing the current marketing trends and all, you'll become a business analyst. Okay. Now, so that's the difference. So Eckhart Guild is an online training company. So we provide certification, we provide courses, we provide course project in the process. So we give both the courses for data scientists, courses for business analysts. Two separate courses are being given by provided by Eckhart Guild, and both are online training. You will have to have, there are lots of theory, lots of practicals, lots of course projects, and you will, at the end you will also get a course completion certificate. And we provide both this training separately, data science course and business analytics course separately, and both has been trained using R, okay, as of now. So you can get both the courses done in Eckhart Guild itself. Okay. Okay, now let us look at some more marketing trends. Let us look at some more marketing trends. So this is a marketing trend. This is a fact that has been taken from Indeed.com. Indeed.com is a where you can search jobs in US, mostly search jobs in abroad. So now look at, when you say analytics industry job are going high and high. So this is from 2000 January. Every year January data is being published here, like monthly data is published here. Now we are in 16th Jan or 16th Feb. Now if you see, the job trend has gone exponentially high. It is not even linear, it is exponentially increasing at high rate. Okay, that means job trend is definitely there in future also. Okay, so we heard about job trend and all. Now let us look into some case studies, okay, where companies has used business analytics or business analytics or statistics into their applications and has got benefits out of it. All of you have heard about Coca-Cola, right? You have Coca-Cola. Now, have you heard of a product called Minute Maid? And many of maybe most of you have known that Minute Maid is a product of Coca-Cola, but not all. If you go and look to the bottle, you will see it's a Coca-Cola product. It's a Coca-Cola product originated by Coca-Cola. Okay, so now out of all the orange juices, it uses pulpy orange, right? Minute Maid is mainly famous for building pulpy orange juices, and is very famous across customers. Whoever wanted to have a mini orange juice in India, at least in India, and packaged orange juice, everybody goes for Minute Maid because it tastes so good. Now, many people think that the world best secret for the Minute Maid is the formula for this Coke company. Coke company means this Coca-Cola company. So not just Minute Maid, everything Coke, or you can say Thumbs Up is also being acquired by Coke. What else? Fanta is a product of Coke. So people thinks the secret formula of success of Coke company is the ingredient formula of Coke. It's not. Every company has its own ingredient, right? And every company knows that what should be the ingredient, how much percentage each of the components should be added to make a juice or make a soft drink. Every company knows that. So what is the key secret behind the success of Coca-Cola company is uh, the the uh, the it says it is the consistency. It is the consistency at which Coca-Cola company produces. So, for example, let's take the Minute Maid taste. You go and pick any bottle. You go and pick any bottle. Drink any bottle in your whole life. You will get the same taste. You will get the same taste, and the consistency in the taste is what the customer likes. That is why they are so they are able to use lots of volume of Coke products. It's the consistency in the sale. So that's the company says now. So Lenny is a past executive director in Coca-Cola. He says that uh, the consistency in the taste has actually promoted a high sale in Coca-Cola company. Now, how does the Coca-Cola engineer identify that? They have tested their product across lots of other companies' product, the lots of other packaged orange juice. So Minute Maid has been compared against other orange juice companies, and what they have done is they have found that the consistency was so same across all the models or all the bottles. Okay, so that is why it was so tasty and people loved it. Now, let's say as a business analyst, you will be given the task to check the consistency of it. Okay, now the question is, hey, the company products millions of bottles. Would I go and check all the millions of bottles? Would you go and drink all the millions of bottles and say, okay, consistency is same throughout. You cannot do, you will die when drinking 100 bottles of mid in one shot, right? So you cannot do that. That means you have to test it on a small sample of bottles, maybe 100 or 200 bottles you have to test. So how do I acquire those? How do I select those small set of number of bottles? How do I do it? What are the assumption I should take when I work on a sample data? Okay, do I only see the variations in those variation of taste in those 100 bottles, or should I assume something about the population? If I calculate some statistics about those samples data, how would I project it for the full millions of bottles of the Minute Maid? What kind of test? What kind of hypothesis test what should I do? What are the different statistical parameter I should be calculating to ensure that the consistency is maintained or not? Okay, so that is where a business analyst guy will come into picture when it does this kind of task. Okay, and one more thing is a bank, right? One more use case is bank. Bank wants to retain customer credit card users because a bank starts making profit from a credit card customer only and only if the customer is more than 1.5 years old. Then bank starts making profit because customer will start making more and more transaction and bank will start making profit. But bank has seen that within a year of purchasing, within a year of taking the credit card, the user starts to fly away from the credit card company, and they stop the credit card, they use some other credit card. So now it's a loss for the company because acquiring a new customer is way higher. The cost of acquiring a new customer is way higher than cost of retaining the same customer. So retaining customer is very important, and a business analyst guy can is a right person to tell you how to retain a customer, or it can at least tell you which are the customers who are likely to uh, churn out or likely to move out of the bank, and you may likely to close their credit card. Okay, so churn analysis is also one of the major case study a business analyst can rightly successfully do it. Okay, so we have so this is all about the introduction about the business analyst, and we have told you why are you will be using, where all it will help, what is the market trend and all. If you have any further questions, please let me know. You can answer any of your questions. Brudes, okay, we'll be now starting the poll. Okay, poll will be taking your suggestions whether because you have to choose the answer out of the poll. So we'll be starting a poll right now. So Brundes, my colleague, will be starting a poll right now. Please opt your answer based on however you feel about the course, whether you like the business analytics area or not. So based on your experience throughout this whole session, please vote for the poll. I would request all to vote for the poll. So, and I got that another question is, so if I complete data scientist course from Eckhart Guild, it's a mix of data scientist business analyst. Yes, it is a mix. It is a mix, but the data science course is little advanced. Okay, little advanced. The prerequisite of data science course is like you should be knowing little bit of R already. You should be knowing little bit of statistics already. We'll assume that the guy who will be joining your data scientist course will know stats and R, will have a primary knowledge about R and statistics already. Okay, if you have already have some knowledge, you can go and join the data scientist course. But if you do not have, the right track is to first go through business analyst course, then move to data scientist course. Okay. Okay, so you have to fill the poll. Brundis, you can also suggest what exactly candidate needs to do. So you have to fill the poll form. So there might be multiple questions asked in that poll. Please give some time to fill the poll and help us actually to collecting your feedback. Okay, somebody says I am from a non-IT background, currently doing my MCA and going, can I go for a? Hey, you are doing MCA, you are from a IT background, okay? Don't consider yourself from a non-IT background. If you're doing your MCA, then you are on the IT industry, or you are from IT background. You definitely you can go and learn R, okay? Uh, and you can definitely earn some experience in that. So, do you even have any SaaS program? Uh,
We don't have SS program,
okay.
Satyam. It's Nishi.
Okay.
Hi.
Yeah. Yeah. So currently we don't have SaaS as a course in academy.
Yeah, currently we don't have. And thank you everybody for attending the webinar. And I would actually like to request you all to please fill this poll because it will help us in creating as well as introducing the course. So please create the polls and give your contribution for the same. I hope you all have enjoyed this webinar.
Nishi, somebody has asked whether there is a recording that they can see. Is it
Yes, yes.
possible?
Yeah, it
Yeah.
will be available for all. It will be uploaded in YouTube also. So we will be providing you the link through which you can actually hear that or see that recording, and as well as it will be available for public. So it will be available soon in just 2 days. Thank you so much, Satya.
Thank you. Thank you.
Thank you.
And thank you, audience, for being patient through 1.5 hour, like 2 hour session mostly, and
We
being
all
patient.
have enjoyed, and I hope that everybody who joined would have definitely enjoyed. And people are polling also, and I believe that we'll get more of the output from this. Thank you so much. Thank you so much, everybody.
Thank you.